Picture this. It is a Tuesday morning in late spring. Your central AC fired up fine last summer. No strange noises, no warm rooms, nothing obviously wrong. Then a technician comes out for a routine tune-up, spends about 40 minutes in your yard, and walks back in with a clipboard. He sits down at your kitchen table and tells you that your system is on its last legs and that you really should be thinking about a full replacement before summer hits. And the quote he hands you is somewhere between $9,000 and $14,000. That moment, right there, is what this entire video is about. Here is the number that should stop you cold. The average cost of a new HVAC system has more than doubled in some markets since 2020. A system that a homeowner paid roughly $7,000 to have installed in 2020 will cost that same homeowner somewhere between $9,500 and $14,000 in 2026 for comparable equipment and quality. That is not a rounding error. That is not inflation noise. That is a structural shift in what this industry charges, and it is happening right now while contractors are standing in your kitchen telling you to act fast. To understand why this is happening right now, you need to go back about 30 years. In the 1990s, the refrigerant running through most residential air conditioners and heat pumps was R22, commonly called Freon. It worked well. Homeowners never thought about it. But R22 is an ozone-depleting substance, and the Montreal Protocol, a global environmental agreement, committed the United States to phasing it out. The groundwork was laid quietly, over decades, and most homeowners had no idea a clock was ticking inside their equipment. In 2010, the United States banned the manufacture of any new equipment that used R22. Existing systems could still run. They could still be serviced. But the supply of fresh R22 was being tightened year by year. Then, in 2020, production and imports of R22 for servicing existing systems ended entirely under the EPA schedule. That is when homeowners with older systems started getting hit with refrigerant bills that were genuinely shocking. Prices that contractors commonly reported as under $10 per pound before the phase-out had climbed to well over $100 per pound at peak scarcity in many markets. That R22 price spike created something important that goes beyond refrigerant. It created a sales script, a template. When a homeowner called because their older AC was losing charge, the contractor could sit down and say, with a straight face and real numbers, that topping off the refrigerant alone was going to cost several $1,000s, and that a brand new system using modern refrigerant was not much more than that repair. The math was sometimes genuinely true, but the script normalized something. The idea that repairing an older system is almost always the wrong financial move. That idea did not go away when R22 did. Follow the incentive and you will find the problem every single time. Here is the incentive structure that matters. Contractors earn significantly more margin on a full system replacement than they do on a repair. A compressor swap or a coil repair is labor-intensive. The parts margin is modest, and the job is technically harder to sell. A full system replacement, on the other hand, carries equipment markup, labor at current rates, and in many cases, manufacturer rebate programs that pay contractors bonuses based on volume of complete system sales. Not repair volume, replacement volume. That incentive structure shapes what gets recommended, even when a repair is the honest answer. Between 2020 and 2023, the industry got hit with a second wave of disruption that had nothing to do with refrigerant. COVID-era supply chain breakdowns hit HVAC manufacturing hard. Steel, copper, and aluminum, the three core metals in almost every piece of HVAC equipment, all saw significant price increases driven by global demand, mining constraints, and trade policy. Tariffs on imported steel, aluminum, and HVAC components added cost directly on top of that. Lead times stretched, prices jumped. Homeowners who remembered getting quotes in 2016 or 2017 were suddenly staring at numbers that felt completely disconnected from their memory of what this equipment cost. At the same time, the industry was consolidating fast. Private equity-backed contractor groups were rolling up regional HVAC companies across the country, combining them under centralized marketing operations and standardized sales processes. These larger organizations brought something smaller, independent contractors often did not have: aggressive, scripted sales training. SPIF programs, which are internal bonuses paid to technicians and salespeople for upselling higher margin systems, became more common. Variable speed systems, communicating thermostats, indoor air quality add-ons, these became standard items on every quote, not optional upgrades. The sales process got more sophisticated, and the average invoice got larger. Then came 2023 and the SEER 2 transition. SEER stands for Seasonal Energy Efficiency Ratio, and it is the rating system used to measure how efficiently an air conditioner or heat pump uses electricity. New federal SEER 2 standards took effect in 2023, replacing the old SEER rating system with a new test procedure and higher minimum efficiency requirements across most regions of the country. The old baseline equipment, the 13 SEER and 14 SEER units that had anchored the low end of the market for years, were redesigned or retired. The cheapest option got more expensive, and the homeowner's mental anchor for what a system should cost became unreliable overnight. That confusion about ratings is not a small thing. When a homeowner cannot compare a new quote to their last quote because the rating system itself changed, they lose their anchor. They cannot tell if they are being quoted an equivalent system or a more expensive one. The contractor knows things you do not, and that gap is where the money goes. A homeowner who remembered paying $8,000 for a 16 SEER system in 2018 has no easy way to translate that into a SEER 2 equivalent in 2026. That knowledge gap, created partly by legitimate regulatory change and partly by the industry's failure to explain it clearly, is extremely useful to a contractor who wants to sell up. Now we get to the current moment. The refrigerant transition that is driving the loudest urgency messaging right now is the phase down of R410A. R410A replaced R22 as the standard refrigerant in residential HVAC systems, and for about 15 years it was the industry baseline. But R410A is a hydrofluorocarbon with a high global warming potential, and the USAIM Act, the American Innovation and Manufacturing Act, committed the country to a 40% reduction in HFC production and consumption by 2024, with steeper cuts continuing through 2036. Manufacturers had to start engineering new equipment around different refrigerants, primarily A2L refrigerants, before the deadlines hit. Beginning in January 2025, new government mandates began limiting which refrigerants can be used in new air conditioning and heat pump equipment. R410A is being phased out of new production. The industry and consumer-facing HVAC companies started warning homeowners about this transition, and the message often sounded like this: replace your system now before the new equipment costs more. Industry and manufacturer estimates, including figures cited by AHRI, the Air Conditioning, Heating, and Refrigeration Institute, projected that the refrigerant transition alone would add roughly 10 to 30% to new equipment costs. Some contractors put a dollar figure on it and said the transition could add $5,000 or more to a typical residential system. Here is the part that the sales pitch usually leaves out. R410A is not illegal overnight. The rules are about phasing down production and changing what is allowed in new equipment coming off the factory floor. Your existing R410A system can still be serviced. Technicians can still buy R410A to recharge a system that has a leak. What will happen over time is that production gets constrained, and as supply tightens while demand from existing systems stays high, prices will likely rise. That is a real concern worth planning around. But it is not the same as your system becoming unserviceable next year. Contractors who present it that way are echoing the R22 playbook, and they are compressing your timeline to create urgency that the actual regulation does not require. Let me put the full cost picture on the table so you have real numbers to work with. HVAC labor costs have risen roughly 5 to 8% per year since 2020, according to Bureau of Labor Statistics data and contractor surveys. Raw material costs for steel, copper, and aluminum are up significantly. Tariffs on imported components have added cost on top of that. New efficiency standards required equipment redesigns that added engineering and materials expense. And the refrigerant transition is layering another 10 to 30% onto equipment prices. A 2026 pricing analysis that pulled all of these factors together called them, quote, real structural changes, not temporary spikes, and warned homeowners not to expect prices to fall back to pre-2020 levels. So let us be honest about something, because this channel does not exist to tell you that every contractor is lying to you. Some of the urgency is real. If equipment costs are genuinely rising 10 to 30% due to regulatory changes, and if you have a system that is 12 or 14 years old and approaching the end of its typical lifespan of 12 to 17 years, there is a legitimate financial argument for replacing it before the next price jump rather than after. The math can actually work in your favor. The problem is not that the argument exists. The problem is that the financial winners in that transaction are not only you. The contractor, the manufacturer, and the distributor all benefit significantly from pulling that sale forward. And that shared incentive is almost never disclosed. Now let us talk about the heat pump piece, because this is where the current sales environment gets genuinely complicated. For decades, heat pumps were pitched almost exclusively in mild climates, the Southeast, the Southwest, coastal regions where winter temperatures rarely dropped far below freezing. The technology worked by moving heat from outside air into your home, and older designs lost efficiency rapidly as outdoor temperatures fell. A homeowner in Ohio or Pennsylvania had little reason to consider one. Their contractor probably never mentioned it. That is not true anymore, and the shift happened faster than most homeowners realize. Modern cold climate heat pumps are engineered to maintain usable heating capacity at much lower outdoor temperatures than older designs. The technology has genuinely improved. Utilities and state programs in northern states, including parts of the upper Midwest and Mid-Atlantic, are now sponsoring heat pump-specific rebates and pilot programs as part of broader decarbonization efforts. Federal tax credits available under recent energy legislation have made heat pumps significantly more attractive financially for homeowners who qualify. For a homeowner in Michigan or Maryland, this is the first time a contractor can credibly offer a heat pump as the primary heat source for the home, not just as a mild weather supplement to a gas furnace. But here is the tension that your contractor may not walk you through carefully. The same technology shift that makes cold climate heat pumps viable also makes them more expensive and more complex than a straight central AC replacement. A heat pump handles both heating and cooling, which means more components, more potential failure points, and a higher installed cost. If you are replacing a central AC that works with a gas furnace, the contractor is now proposing to change your entire heating and cooling strategy, not just swap a box. That is a fundamentally different conversation than replacing like for like, and it deserves a fundamentally different level of scrutiny. Let me give you a concrete scenario so this is not abstract. Imagine you are in suburban Columbus, Ohio. You bought your house 4 years ago. It has a gas furnace that is 9 years old and running fine, and a central AC that is 11 years old and still cooling. A contractor comes out, looks at both, and tells you that your AC is near the end of its life, and that you should seriously consider replacing the whole system with a heat pump now, while the federal tax credit is still available and before R410A equipment gets more expensive. Every single one of those statements can be technically true. And the quote he hands you is $11,000. The question is not whether any of it is true. The question is whether it is the right move for you specifically right now, given your numbers. To answer that question honestly, you need to run 4 specific variables. First, what is the actual efficiency difference between your current system and the proposed replacement, measured in SEER2 for cooling and HSPF, the heating seasonal performance factor, for heating? Second, what are your local utility rates per kilowatt hour, and what is your current annual energy spend on heating and cooling? Third, what rebates and tax credits actually apply to your specific situation, your income, your utility provider, and your equipment choice? And fourth, what does your contractor's own estimate say about the simple payback period on that investment? If he cannot answer all 4 of those questions with real numbers, the conversation is not finished. Now I want to spend a minute on one of the most counterintuitive things about modern high-efficiency systems, because it is being used in both honest and dishonest ways right now. Variable speed or variable capacity systems, which are the high end of the current market, are designed to run continuously at low speed for long stretches rather than cycling on and off in short blasts like older single-stage equipment. This is actually more efficient. The system maintains a steadier temperature, removes more humidity, and uses less energy overall than a unit that hammers on at full power and then shuts down. But it runs almost all the time, and that feels wrong to a homeowner who was told for 30 years that a system running constantly means something is broken. A contractor who explains this clearly is doing you a service. A contractor who uses your unfamiliarity with this behavior to create doubt about your current equipment is doing something else entirely. The script sounds like this. Your old system is short cycling, which means it is not dehumidifying properly, it is wearing out its compressor faster, and it is costing you more to run. All of that can be true of a failing single-stage system. But it can also be a description of a perfectly normal older system that is simply running the way it was designed to run. Without actual efficiency measurements, actual energy bills, and an honest comparison, that pitch is a feeling, not a fact. Let me walk you through the cracked heat exchanger scenario, because this one comes up constantly, and it is one of the most consequential moments in any furnace conversation. A heat exchanger is the component in your furnace that separates combustion gases from the air that circulates through your home. A confirmed crack in a heat exchanger is a real safety concern because it can allow carbon monoxide to enter your living space. That is not a scare tactic. It is physics. But the phrase cracked heat exchanger has also become one of the most commonly cited reasons for recommending full furnace replacement. And the diagnosis is not always as clear-cut as it sounds. Here's what you need to know. Code interpretations on heat exchanger replacement vary. Some cracks are hairline surface cracks that are not actively passing combustion gases. Some are stress fractures that are genuinely dangerous. The diagnosis requires more than a visual glance, and some contractors use the term loosely. Phrases like red tag, unrepairable, or parts no longer available are sometimes used without documentation or a clear explanation of what was actually found and why repair is not an option. In an environment where full system replacement carries significantly higher margin than a component repair, you should always ask for the specific finding in writing, and you should always have the right to get a second opinion before authorizing a full replacement. Let me bring this back to the heat pump versus central AC decision specifically, because for a homeowner in the upper Midwest or Mid-Atlantic right now, this is the real fork in the road. If your central AC fails or is approaching end of life and you have a gas furnace that still has years of useful life, you have two basic paths. Path 1, replace the AC with a new central AC unit and keep the furnace. This is a like-for-like swap, lower upfront cost, and your heating strategy does not change. Path 2, replace both with a heat pump system, either as a standalone or as a dual fuel setup paired with your existing gas furnace as a backup. Higher upfront cost, potential for significant energy savings depending on your utility rates and heating fuel costs, and potentially meaningful rebates and tax credits. The case for the heat pump path is strongest when three things are true at the same time. Your current heating fuel, usually natural gas, is expensive relative to electricity in your market. Your local utility offers a meaningful rebate for heat pump installation, which some northern utilities now do as part of decarbonization programs. And you qualify for the federal tax credit, which can be a significant offset on the installed cost. If all three of those are true, the math can genuinely favor a heat pump even at a higher upfront cost. But if your gas rates are low, your utility offers no rebate, and your income or tax situation means the federal credit does not fully apply, the payback period can stretch to 15 years or more, which changes the calculation entirely. The case for the straight AC swap is strongest when your gas furnace has significant remaining life, your local gas rates are low relative to electricity, and the upfront cost difference between an AC replacement and a full heat pump system is large enough that the payback period does not make financial sense in your planning horizon. A straight AC swap in 2026 will still cost more than it did in 2020, but it is a narrower scope of work with a more predictable outcome. You are not changing your heating strategy, you are not adding complexity to your system, and you are not betting on utility rate forecasts over a 10-year period. For some homeowners, that is the right answer even if a contractor is pushing hard in the other direction. There is a third option that almost never gets mentioned in the sales pitch, and that is the dual fuel system. A dual fuel setup pairs a heat pump with your existing gas furnace. The heat pump handles cooling and handles heating down to a set outdoor temperature, typically somewhere around 30 to 35 degrees Fahrenheit, where it is most efficient. Below that threshold, the system automatically switches to the gas furnace for heat. This gives you the efficiency benefits of a heat pump during moderate weather, the reliability of gas heat during the coldest days, and a lower upfront cost than replacing both systems entirely. It is a genuine middle path, and in colder climates, it often makes more financial sense than a full heat pump-only system. Now let me address the efficiency argument directly, because contractors often use it as a closing argument for replacement. They will say something like, your old system is probably running at 10 or 11 SEER, and a new system runs at 16 or 18 SEER2, so you are throwing money away every month. That statement can be directionally true, An older, low-efficiency system does cost more to run than a modern, high-efficiency one. But the size of the savings depends entirely on your local utility rate per kilowatt hour, how many hours per year your system actually runs, and what size system you have measured in BTUs. Without those three numbers plugged into an actual calculation, the efficiency argument is a feeling, not a financial projection. Here is a practical example. A homeowner in the Mid-Atlantic running a 10-SEER central AC that is sized at 36,000 BTU, which is a 3-ton system, in a climate that requires roughly 1,000 cooling hours per year and paying 12 cents per kilowatt hour for electricity, will spend roughly a certain amount annually on cooling. Upgrading to an 18-SEER 2 system of the same size cuts that energy consumption roughly in half. At 12 cents per kilowatt hour, the annual savings might be in the range of $300 to $500, depending on exact conditions. At a $10,000 replacement cost, the simple payback from energy savings alone is 20 years or more. That does not mean replacement is wrong. It means the efficiency argument alone rarely closes the case. So when does the replacement case actually get strong? When you layer multiple factors together rather than relying on any single one. If your system is over 12 years old and using SHAR 410A, and a repair would cost more than a third of the replacement cost, and you have a meaningful rebate available, and your system is undersized or oversized for your home, and you are in a region where electricity rates are favorable relative to gas, the combination of those factors can genuinely tip the math toward replacement. The problem is that contractors rarely walk through all of those factors systematically. They lead with the one or two that are most emotionally compelling, usually the regulatory deadline or the efficiency gap, and let the homeowner's anxiety do the rest of the work. Let me talk about something that almost nobody explains clearly, and that is the ductwork question. When a contractor proposes a new heat pump or high-efficiency AC system, the ductwork in your home matters enormously. Modern variable speed systems are designed to move air at lower static pressure over longer periods. If your existing ductwork is undersized, leaky, or poorly configured for that airflow pattern, the new high-efficiency system will not perform at its rated efficiency. In some cases, the contractor will tell you up front that a duct modification or replacement is required, and that cost gets added to the quote. In other cases, it does not come up until after the system is installed and not performing as expected. The same issue applies to electrical service. Heat pumps require dedicated electrical circuits, and in many older homes, the electrical panel does not have the capacity to support a new heat pump without an upgrade. That upgrade can add anywhere from a few hundred to several $1,000s to the total project cost, depending on your panel, your local code, and your electrician's rates. A complete and honest quote for a heat pump replacement in an older home should include a panel assessment. If the contractor gives you a heat pump quote without mentioning your electrical service, you are not looking at a complete picture of what this project will actually cost. There is also the line set question. The copper refrigerant lines that connect your outdoor condenser to your indoor air handler are called the line set. Many contractors now recommend or require replacing the line set when installing a new system, particularly when switching refrigerants from R410A to a new A2L refrigerant, because the new refrigerants have different pressure characteristics, and the old line set may not be rated for them. That is sometimes a legitimate requirement and sometimes a margin-generating add-on. A line set replacement adds labor and materials cost to the job. Ask specifically whether your existing line set is compatible with the new refrigerant and what the code requirement is in your jurisdiction before agreeing to that add-on. Let me give you a framework for reading a quote. When a contractor hands you a proposal for a full system replacement, there are 5 things you should be able to identify clearly before you sign anything. 1. The exact equipment model numbers for both the outdoor unit and the indoor air handler or coil, so you can look up the SEER 2 and HSPF ratings yourself. 2. The BTU capacity of the proposed system and the manual J load calculation that justifies that size. 3. An itemized breakdown of labor, equipment, refrigerant, and any add-ons like line sets, thermostats, or permits. 4. The warranty terms for both parts and labor, including who backs the labor warranty. And 5. The total installed cost with no items marked as to be determined. The manual J load calculation deserves its own moment. Manual J is the industry standard method for calculating how much heating and cooling capacity your home actually needs, measured in BTUS. It accounts for your home's square footage, insulation levels, window area, ceiling height, local climate data, and duct configuration. A properly sized system is critical to efficiency, comfort, and equipment longevity. An oversized system will short cycle, meaning it blasts on, cools the air quickly, and shuts off before adequately removing humidity. An undersized system runs constantly and cannot maintain comfort on the hottest or coldest days. Many contractors skip the manual J entirely and just match the size of whatever they are replacing. That is not engineering. That is guessing. Now let me address the warranty structure, because this is another area where the fine print matters more than the headline. Most major HVAC manufacturers offer 10-year parts warranties on registered equipment. But that parts warranty covers the component cost only, not the labor to install the replacement part. Labor warranties, which cover the cost of the technician's time to do a warranty repair, are typically offered by the installing contractor, not the manufacturer. They usually run 1 to 5 years. After that, a warranty repair on a failed compressor might cost you nothing in parts, but several hundred to over $1,000 in labor. Ask specifically what the labor warranty covers, how long it runs, and what happens to that warranty if the installing company is sold or goes out of business. Let me pull back and look at the big picture of why all of this matters right now, in 2026, specifically. The combination of rising equipment costs, the R410A phase-down messaging, the SEER 2 transition confusion, the heat pump push, and the consolidation of the contractor industry into larger, sales-driven organizations has created an environment where the pressure to replace is higher than it has ever been. And the homeowner's ability to evaluate that pressure independently is lower than it should be. A 2026 pricing analysis described these forces as real structural changes, not temporary spikes. That is true, but structural change in costs does not automatically mean your specific system needs to be replaced this year. Those are two different statements, and they are being conflated constantly. This is not complicated. It was just never explained to you. The HVAC industry has a structural profit incentive to sell full system replacements over repairs, and that incentive has been amplified by a series of legitimate regulatory and cost changes that also happen to make the urgency pitch more credible. The regulations are real, the cost increases are real, the technology improvements in cold climate heat pumps are real. But real changes in the macro environment do not automatically translate into a correct recommendation for your specific home, your specific system, and your specific financial situation. The contractor's job is to sell. Your job is to evaluate. And you can only evaluate if you understand what you are actually being asked to decide. Before you sit down with any contractor, do 3 things. First, pull your last 2 years of utility bills and calculate your average monthly and annual spend on heating and cooling separately if you can. This gives you a real baseline to evaluate any efficiency savings claim against. Second, look up your system's model number, which is on the data plate on the outdoor condenser unit, and find its original SEER or SEER, 2 rating and its age. Third, check your state's and your utility's current rebate programs for heat pumps and high-efficiency AC. These programs change frequently, and the amounts vary significantly. Going into a contractor conversation with those 3 things in hand changes the dynamic of that conversation entirely. Get at least 3 quotes. This is standard advice that most homeowners skip because the process is uncomfortable and time-consuming. But in a market where prices range from $9,000 to $14,000 for comparable systems, the spread between quotes can easily be $2,000 to $4,000 for identical or near-identical work. More importantly, getting multiple quotes forces each contractor to be specific about what they are including. When you tell a contractor that you are getting 3 quotes and that you will be comparing line by line, the level of detail in the proposal tends to improve immediately. That specificity is what you need to make a real decision. Here is what a legitimate contractor should be willing to do and say. They should be willing to give you a written, itemized quote with model numbers, BTU capacity, and a clear statement of what is and is not included. They should be willing to explain why they sized the system the way they did, ideally with a manual J or at minimum, a clear explanation of their sizing methodology. They should be able to tell you what the expected efficiency savings are in actual dollar terms based on your utility rate, not just in SEER 2 numbers. And they should be willing to tell you honestly whether your current system can be repaired and what that repair would cost, even if their recommendation is replacement. If a contractor will not do those things, you have your answer about how that conversation is going to go. The HVAC industry is not uniquely corrupt. Most technicians are skilled people doing honest work. But the structural incentives in this industry, the margin difference between repair and replacement, the manufacturer rebate programs, the consolidation into larger sales-driven organizations, and the genuine regulatory changes that make urgency messaging credible, all push in the same direction. They push toward replacement, toward higher-end systems, toward selling now rather than later. Understanding that structure does not mean distrusting every contractor. It means knowing what questions to ask, what documents to request, and what numbers to run before you say yes to a 5-figure decision. That knowledge is the only thing that closes the gap between what you are told and what you actually need. If this video gave you something useful, the best thing you can do is share it with someone who is staring down an HVAC decision right now, because this is exactly the moment when the information matters. There are 2 more videos on this channel that go directly with this one. The first breaks down how to read an HVAC quote line by line, including the specific line items that are almost always overpriced. The second walks through the heat pump tax credit and rebate landscape in detail, including what actually qualifies and what does not. Both are linked in the description. And if you have a quote sitting in front of you right now and something about it does not feel right, drop the details in the comments. I read them, and sometimes the answer is simpler than you think.